Hello, grade 8. Today, inshallah, we will study together chapter 14, scatter plots and association. First, we have to know how we are going to determine association. Association in a scatter plot describe how data is related. So association means relationship, and association in scatter plots describe how data is related. Positive correlation or positive association means that the both data sets increase together. Negative association means that as one data set increase, the other data set decrease. No association means there is no relationship between the sets of data. So we have here 3 examples for each relation. For the first one, we can note that once the x-axis increase, to the y-axis increase too. Then the two variables x and y increasing together. For this reason, we said that positive correlation or positive association means that the both two data increase together. For the second one, negative association, one variable increase, second variable decrease. So if we look at the x-axis here, so we can note that with 1, if here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 0 and 9, and then we have 1 and 8, 2 and 6. And this one, it will be negative association. For the third one, we can note that we don't have a specific relation, or there is no relation between the two sets of data. Like if I will say your hair color and your rank in the class, there is a relation between your hair color and to be the first one in the class. There is no relation between those two sets of data. For this reason, we will say that this one is no correlation. So positive correlation, as I said, both of them, it will increase together. Negative correlation, and they move down like this. No correlation, it will be random points without any relation. If along a line, then they are got a linear association. So we can say for the first one, this is a linear association. For the second one, this is a linear association, but with negative. But for the last one, we can't draw a line to connect all the points together. So the scatter plot, also called a scatter diagram. They are a graph of ordered pairs of data. The data is plotted as points scattered on the coordinate grid. So let's take this example together. And in this one, Tala had a dog, walked a business. What happened to her business as she raised her price per dog? Then, if we will translate the data, which we have it here in this question, we will note that once she's going to increase the price, so the number of dogs, it will decrease, which she's going to sell it, it will decrease. Then let's watch this example together.
$1 for walking dogs. You see that? So what happened as she increased her prices? Let's look at the number of customers she had. She had 20 customers and she was charging $1 per dog to walk. And then she raised her price to $2 per dog, and she lost a customer. She went down to 19 customers. See that? When she raised her price to $3 per dog, she dropped to 16 customers. She lost 4 customers. And then she kept the 16 customers, even though she raised the price to $5 a dog. See that? And by the time she raised her price to $14 a dog, she only had 1 customer left. Well, that wasn't smart, was it? So, when she charged $1 per dog, she had 20 customers, and she made $20 per day. As she increased her prices, she lost customers. Now, when she charged $9 per dog, let's find that your 8 is 10, so 9 is right in the middle. She had 10 customers. See that? She had $90 per day with the 10 dogs compared to $20 per day with.
So we can note here. Once she charged $1 per dog, she had 20 customers and made $20 per day. Also, she increased her prices. She lost customers because when she charged $9 per dog, she made 90 per day with 10 dogs.
20 dogs. So that's half the work. Only 10 dogs from 20 dogs. But she was making almost 4 times the money that she was making with only half the amount of dogs. So she probably should have kept it around there, right? When she charged $12 per day, she made only $48 because she dropped down to 4 customers. See that? So now she wasn't making as much. She was doing 1/5 of the work with only 4 dogs instead of 20. And she was making about double the money. Instead of $20, she was making 48, a little more than double. When she was charging $9 per dog and had 10 dogs, that was the tipping point. That was the best, place for her to be money-wise. If she keeps increasing her price, she's going to have no customers left. If she went up to $15, she might lose that one last customer. See that? Now, there's a negative association in the relationship between her raising her prices and keeping her customers. See that? That's a negative relationship. I mean, a negative slope coming down in it. A positive association is going to follow a line with a positive slope. A negative association is going to follow a line with a negative slope. And if there's no association, it means by various data, those x and y values that change in one variable have no predictable relationship to the other variable. So there's no association. It's kind of clustered around, not even clustered, it's kind of scattered around. It's scattered around the graph. See that? These are clustered coming down negative, these are clustered coming up positive, and these are just scattered all over the place. There's no association. If by various data, the x and y values have a non-linear association, then the data shows a positive or negative relationship. But the points don't fall along a line. It is non-linear. The only way for it to be linear is if it falls along a line. So you can have non-linear association and it won't be along a line. And it could be a positive or negative relationship. Okay? So it doesn't have to absolutely be one or absolutely be the other. You can mix and match this. Okay? Take a look at this one. What if you saw this? You can see that it started up here and it's slowly going down. See this? So if the values start up here and then they slowly start going down like this, they're not making a straight line. See? So even though this has got a negative association because it's coming down, it's not linear. See that? So that's what I'm talking about. It doesn't have to be linear to be negative or positive. Okay? All right. So that's determining association. And we're going to move on to the next unit. We're going to talk about trends. Okay?
Okay, so this is the second part of our lesson, which we can make a scatter plot, graph our studying as the independent variable, and the test grades as the dependent variable. And we want to determine what is the trend do you see in the data. So We have the data now here in this one. Let's listen together. And we want to plot this data in the scatter plot.
So like if we look at the way the graph is set up, so actually we should have, if we wanted to do it according to what the author said, we want to make this our test, and that's the test grade is our line. So I think now we have yes, right, really correlation with what the author said. So here you want to go ahead and pause and create your point. And then remember that the first point was 0 and 75. So you want to go on your x-axis, you want to go to 0.
We will plot the points.
So subtract these. What we saw was, we saw that this is 0.
This is the hours
75.
spent studying, and this is test grade.
0.5 and 8. Here are your two 1 hour grades. 8 and 85. Your 1.5 hour grades. 85 and 95. Your 2 hour grade. 90. Your 3 hour grade. 100. And your 4 hour grade. 95. Okay, so I hope you can grab those exactly out there. Now, it says to make a prediction about the relationship between the two. One good sample prediction would be the more you study, or the more hours spent studying, your test grade will be higher. And of course, we already made that scatter plot. And going back looking at the scatter plot, it says, well, what trend do you see? So let's look back and see the trend. As you notice, the data is going as it goes from left to right on the x-axis. This data is, in general, going up in value. Okay? So, in general, the test scores increase as the number of hours increase. And then it says, here's one justification. Do you think that studying for 10 hours will greatly increase a student's grade? Just go back and look at the scatter plot. And you think, and you see 5 hours here, but look at the trend. Look at the trend. Would studying another 5 hours?
So what do you expect? That you spend more hours. Did you see the graph? The graph starts with 1 hour, he got 80, and then for half an hour, and this 1 hour he got 80, 90, and then 1.5, 85, and then 95, and so on. But we look at this one, after 3 hours you got 100, and after that for 4 hours the scale it will go down. Then when we back to the question, he said that after 10 hours we will predict here.
Well, no, because the graph shows a general upward trend, but the grades cannot exceed what? 100.
So this is was the first part in our lesson today about scatter plot, and we will continue in the next session, inshallah. This is lesson 14.1 in our book, scatter plots.